Welcome once again to the 2023 Vermont Organics Recycling Summit, organized by the Composting Association of Vermont in partnership with Vermont's Agency of Natural Resources. This year's summit is being held as a kickoff event for International Compost Awareness Week, which starts on May 7th. International Compost Awareness Week is the largest and most comprehensive education initiative of the composting industry. And this year's theme is healthier soil, healthier food, compost. I just want to give a shout out. The poster on the right here on my slide is from a project from UVM students in Dr. Deb Nair's Composting Ecology and Management class. They create International Compost Awareness posters based on the theme every year, and the full collection is showcased on CAH's website at compostingvermont.org/VORS. And each image on the website, if you click on it, then includes the students' full story about their inspiration for the poster that they created. I'm Natasha Duarte, the director of the Composting Association of Vermont and facilitator for today's session. Before we get going, I'd like to give a huge thanks to all of our sponsors who allow us to put this whole program on free of charge for you all. They include Community Bank, Eco Products, Nature Cycle, Vegware, Vermont Natural Ag Products, Addison County Solid Waste Management District, Agrilab Technologies, the Vermont Produce Program from the Agency of Agriculture, Food and Markets, RMI, and Vermont Sustainable Jobs Fund. So perhaps some of you were able to join us this morning or earlier this afternoon for the State of Organics and our keynote from Brenda Platt. And we're now moving into our 3 p.m. session, expanding site capacity by adding aerated composting to turned windrow operations. And with that, I'm going to stop sharing my screen and invite Brian Jerose to start sharing his screen while I introduce our speakers. So we're joined today by Brian Jerose, who's been president of Agrilab Technologies, Inc. since 2012. AGT sells compost, aeration, and heat recovery units and other farm and composting equipment. Brian and his team also provide planning, design, development, implementation, and ongoing operating support to farm, municipal, commercial, and nonprofit clients in Vermont and several other states and countries. He's worked on a range of composting, watershed protection, and sustainable development projects, and he lives in Fairfield, Vermont. Robert Spencer is going to be joining Brian. He's been the executive director of the Windham Solid Waste District since 2011. Windham Solid Waste Management District serves 19 member towns in southwestern Vermont and operates a transfer station, composting, recycling, household hazardous waste, and education programs on a Brattlegrow property that includes a closed landfill covered by a solar array. Bob is also an environmental planning consultant who works with composting facilities and other clients in Massachusetts and around the country. He has operated several composting facilities and is also contributing editor for Biocycle, and he lives in Vernon, Vermont. And full disclosure, both Bob and Brian are on my board of directors, on the Composting Association of Vermont's board of directors. So with that, I will turn it over to Brian and Bob. Thanks so much.
Yeah, well, thank you, Natasha, and thanks everyone who's tuning in here. Brian and I have collaborated here for several years to get a expanded compost facility under construction, and we're going to describe that process. Get just an aerial drone shot of our very low-tech composting facility. We have become the second largest food scrap composting facility in Vermont, following the Chittenden Solid Waste District's facility in Williston, Vermont. We're sort of hoping to become more like them, as you'll see here today, using some higher technologies. Just to orient you to this, we are on a site that is adjacent to a 20-acre capped landfill that has 5 megawatts of group net metered solar on it that's owned by the district but leases to a private company. You can see some arrays there. When you come into the entrance to our composting facility, on your right as you come in are bunkers where we store finished screen compost, and that makes it easy for our distributors to pick it up. Then it also makes it fairly accessible for haulers who bring in food scraps. We have commercial haulers that bring material into us, and I'll talk more about that. You see the light colored material to the upper right of the aerial, that's sawdust that we get from a house manufacturing company. It's a mix of sawdust and chips. And we also take in leaves from other municipalities. So then basically that's the southern side of the site. We build the windrows where you see kind of a light colored mix, the top first windrow, and then we progress to the north or the bottom of the slide over a period of 6 to 12 months. And then our screener, you can see that in the bottom corner. That's where we are today. And this week, screening lots of compost, trying to keep up with the demand. Yes, we do have a significant demand for our product. We take mixed residential organics. This is from the town of Brattlegrow. For 10 years, they've offered curbside food scrap collection. And the way the program operates is they have every other week trash collection, weekly food scraps, and weekly recycling. They also have pay by the bag or pay as you throw. So every other week collection increased the number of participants, and pay as you throw increases. So we're up to over 600 tons per year of that mixture you see. You can note the substantial amount of cardboard and paper products. We are about diversion as a solid waste authority. We don't try to have certified organic compost, which would bounce a lot of these materials out. And we reduce the amount of carbon that we have to add due to the presence of the other fiber. The leaves that we get from the town of Brattlegrow, there really aren't enough to sustain our carbon needs. There's only 2 collections curbside in Brattlegrow, 2 weeks in the spring, 2 weeks in the fall. So we have to go outside of the region to get more carbon, as I mentioned. Next. We have a number of commercial food manufacturing businesses that bring material to us. One of them is a gluten-free bread company called Against the Grain, and they have been expanding exponentially over the last 5 years. And one of the ingredients in their mixture is eggs. And they have a machine that extracts the contents of each egg to use in their recipes, and we get their eggshells. Those are in biodegradable polymer bags, but we get literally millions of eggshells, and 2 compactor loads per week. Occasionally we have off-spec bread and pizza shells, but I wanted to point out the eggshells because it's actually a slow release nutrient source for our compost. And there's little white flakes in the finished product. And fortunately, it's predominantly not plastic. Next. So this project is really centered around state regulations. And in Vermont, we have a very expedited program for starting as a small food waste composting facility. Basically, it's a permit by rule or registration process where you can process up to 2,000 cubic yards per year of food waste, up to 3,000 cubic yards of yard waste. Total permitted capacity is 5,000 cubic yards. We have a separate approval to take soiled paper and cardboard, which, as I mentioned, is a good carbon source. We have a very low-tech operation using turned windrows with a loader. We have a large 5 cubic yard John Deere 644K that mixes the material and turns the piles. We have a a smaller John Deere backhoe with a 1.5 cubic yard bucket that we use to load our trommel screen. So we have really 3 pieces of equipment that we use primarily. We comply with the regulatory monitoring and to document our pathogen fill temperatures as well as compost product testing. And our employees have all been through the Vermont operator certification for compost facilities. Mentioned the Brattlegrow curbside program. It actually started in 2013, and as you can see, it's grown over the last several years, and we'll probably hit 700 tons this year. We had a slight dip. Well, we didn't accelerate as much in 2021, partly due to COVID, as was mentioned in the opening session, closures of schools, etc. Our total tons processed has also increased, and this is where we had a dip in 2020 after 2021 due to the closure of a fairly large national company that had an operation in Brattlegrow, Vermont called Vermont Bread Company. And that was a significant loss to our feedstocks. We also proactively, notified the Vermont DEC that we were exceeding our cubic yards. The regulation is written in cubic yards. We weigh every vehicle, and so our records are in tons. We spent 2 years ago now, when we realized we were knocking on the door of our permit, we spent a couple of months documenting every load that came in and estimating the percentage that was paper and cardboard versus food scraps. And we have confirmed, any way you look at it, we were exceeding our permitted capacity. And at that point, the Vermont DEC staffs said, well, what are you going to do about it? And one of the first things we did is divert one of our out-of-state sources, which was Keene State College. And between Vermont bread closure and diverting Keene State, we went back into compliance for about a year. That has since we've been back above the capacity, permitted capacity, for the last year or so. So the DEC staff said, well, if you can get a new facility developed, we can work with you and not have to, have you divert more material from your local sources. And so they've been really accommodating as we worked to implement an expanded facility, which is what we're going to talk more about here. So the organics we receive are from a wide range of sources, basically throughout Windham County. It's a relatively rural county of 37,000 people. Brattlegrow, our largest community, is 12,000. We estimate somewhere over 2,000 Brattlegrow residents participate in curbside. We don't really know how many, but as I said, once every other week trash collection started, the numbers went up. Once pay as you throw started, numbers went up. Apartments above 4 units are considered commercial generators and are not served by the town of Brattlegrow's program. Brattlegrow operates the curbside collection with a private company, Triple T Trucking, which is now Casella Waste as of last month. And in addition to the residential program in Brattlegrow, we have numerous restaurants. I mentioned the bread manufacturers. There's actually a vitamin manufacturer, schools, colleges, and supermarkets, food co-ops. In addition, our transfer station has a drop-off for residential food scraps and several other transfer stations in the region that are in our district also, and some of those materials come to our facility. So it's a wide range of, institutional, commercial, residential materials. Next. So our overall goal is to increase the capacity. And we're doing it, hopefully, we haven't built it yet, with aerated static pile and also heat recovery, which you'll hear more about. More detail on this is we needed some sort of accelerated process because of a relatively small footprint that I showed in the beginning. It's approximately 2.5 acres of active land use area for composting. It's on a 35-acre site that the district owns, but 25 of that is closed landfill. And then we have a transfer station, we have a closed MRF building that's still used to bale cardboard. So the facility is quite busy. We needed a faster cycle time from when materials came in until they go out. It's anywhere from 6 months to a year right now. We need to decrease that time in order to increase our throughput. And we also wanted to use the aeration system in conjunction with turned windrow, and we'll show you how that design is set up. Heat recovery, we'll talk about that. And then we needed to have a reasonable budget, and I'll talk about the financing, and all the while staying in compliance with the Vermont A&R regulations. Next. So Brian, why don't you describe the system that we're anticipating using? Just so everyone knows, we will be putting this project out to bid, and we have not selected Agrilab, but they have been part of our initial design. We retain them to do initial design services, and they will be bidding on the project, of course, and not sure how many other companies might, but there are a couple others. Take it.
Great, thanks, Bob. So just a quick review of what compost aeration and heat recovery is. Most folks are familiar with the turn windrows, where we see loaders or other equipment that flip and agitate the piles, both to mix the different feedstocks and particles, but also to get oxygen. Forced aeration or aerated static piles, there's different terminology for it, is essentially setting up piping networks in or below the compost piles in order to push or pull more oxygen into that material. Since it's an aerobic process that wants oxygen to speed it up, rather than the 1 or 2 times a week that a typical turned windrow operation might have oxygen introduced through the turning, an aeration system can introduce that oxygen 10 or 12 times a day, depending on the timer schedule that's set up. So that's one of the main reasons why an aeration process can accelerate the decomposition, is you're providing more oxygen to those microbes. Our process specifically is what's shown here. We provide the blowers, the valve banks, the timers, in some systems, these specialized heat exchangers, and then sensors and controls to operate and set the timing for the system. Oftentimes they're in blocks of 4. We find so far that that's been a good interval, or a good series of numbers where you can sequence aeration on for 1 and have 3 off, and then cycle through over anywhere from 20-minute to 1-hour cycles of aeration on. Primarily, we operate in the negative aeration mode, which is the suction. So we're actually drawing air and the hot steamy vapor out of those piles once they're up to desired temperatures. So that's what these lines indicate, is that air and vapor is being drawn into the equipment. It goes across a heat exchanger. The blower or aeration fan is what is the force, pulls that through the system. And then these ductwork can either direct it out to exhaust. If needed in urban or commercial setting, we can run it through a biofilter for extra odor control. It can also be recirculated back to the compost pile. So when we talk about winter operations, we can maintain or start a pile rather than pulling 10-degree Fahrenheit air into a brand new mix of leaves and food scraps and so forth. We can actually push warm air from these other active piles into it and jumpstart the process. So there's some good front end acceleration benefits as well. Once the system is going, all that hot vapor as it cools off generates a lot of condensate. I say a lot, but it may only be 50 to 500 gallons a day, depending on the scale of the site. But the heat exchanger heats up a heating loop. So analogies would be to solar thermal or geothermal. We're not making electrical power here, but we are capturing thermal energy that has been used at a number of different sites for everything from heating wash water on farms, radiant floors, greenhouses, or running to a second heat exchanger to heat up air that's then used to dry down finished product prior to screening. So there's a few different ways that can get used depending on the site's particular needs. We've, over the last few years, built up a good list of projects where we've implemented this compost aeration and heat recovery process. Right next to Brattlegrow is a livestock and dairy farm, Vermont farm, that Jeff Dunkley and family operate. They have a pretty simple unit that more or less sucks the tailpipe exhaust out of a rotary drum composter that they use with separated dairy manure solids. Larger installations in hybrid farm situations, commercial situations include Foster Brother Farms, the Vermont Natural Ag Products, the folks who make Moodoo. Some of the shots I'll show later are from that site. Tamerlane Farm up in Lyndonville. Some folks mentioned that site. And then several others around New England and all the way out to Michigan. Bob's had the benefit of being able to see at least a couple of these sites, 3 of them, I believe. So that informed his team's decision to pursue this type of approach for their facility. And this process isn't, while our first sites were certainly on dairy and livestock farms, we've been able to work with a wide range of feedstocks. The Vermont Natural Ag Products, for example, in Middlebury probably takes in a dozen different types of feedstocks. And then some of the other commercial sites out in Michigan are primarily leaves and wood chips, food scraps, and such. So this technology works with a range of compost inputs and is adapted to what the site actually needs. These next few slides are focused on just helping people visualize how these systems are actually put together. So these first few shots are kind of the construction stage, and then a couple shots that will end with what it looks like when it's operating. To point out, some of the early compost or the early heat recovery projects off of composting include physically putting irrigation or other tubing in a compost pile. And while that was a great innovative way to take advantage of it, it's known as the Jean Pain method. It can work well for a homestead or do-it-yourself operation. It's not very practical in a commercial or larger scale operation to have all that pipes or tubing in your compost. And it's not even the most effective way to gather the energy. So these systems involve setting up either the pipes on grade under the piles, or you can build trenches. So this is pretty similar to what's proposed at the Windham site. Looking out on the pad, wanted to call out here that because we're also trying to do the heat recovery in beyond just putting these trenches into the working pad where we'll be able to pull and push the aeration, it also maintains the temperatures to the best of the ability. So when that vapor is drawn into the heat exchange unit, it's at the highest temperature possible. One of the other things that happens with negative aeration and is less of a concern with positive aeration is the accumulation of condensate. Again, picture 150 degree vapor, high humidity. Anytime that vapor hits a cooler surface of a pipe wall or any point along the path, you're going to start condensing and phase change into liquid. If you don't have a good means by which to drain that out, you can create a blockage and interfere with the effective aeration. So over time, develop different sump systems. In this case, here's a septic style tank where the pipes go in. There's an extended trap, kind of a bigger version of what you see under your sink. and that allows the water to drain out without having the suction of the fans pull that instead of the compost pile. And interestingly, I just wanted to call out, most of the water that we do see is condensate, not leachate. There is occasionally the rare circumstance where there's so much moisture going through the pile that you do have nutrients that need to be treated. But oftentimes the mass of compost, even in an outdoor pad, is enough to absorb snow and rain melt. But we do have this set up so if you do have leachate, it's properly handled and sent to either a retention pond or appropriate filtration area. A little more view of a pad coming together. Kind of see the sub-base material, the trench being filled up to it, and then surface certain areas where it's more shallow to surface and you want to protect the pipes. Concrete may be placed over those sections. I could see the material being brought up to grade. Over to the left, you can see that's the compost aeration and heat recovery unit. So all the mechanical equipment, the blowers, heat exchanger, sensors, etc., are in there. And that's where the pipes connect from under the piles, run underground, go through the sump, and then those circles are the pipe ports where it's connected. So we build this equipment up in our shop in Cambridge, Vermont, off of Route 15, Lamoille County, and then deliver these to the various sites as much of a plug and play equipment as possible. And then here we've got the final, in this case, asphalt surface. I'd say the majority of sites use concrete or gravel as a surface, but in this case, asphalt was most cost effective and has held up well. This pad has been in place since 2017 and is not showing any excessive wear or degradation. One interesting thing I'll also call out is there are certainly a lot of systems, and we've made them as well, with cover plates, but as long as your process allows equipment to be straddling and going in and out, placing these coarse, clean wood chips around the pipes has been an effective way to build a plenum and avoid clogging. By coarse, clean wood chips, I mean not a lot of fines or sawdust, so it's kind of loose, but it is still enough of an effective filter. So wet manure or other wet compost particles are able to be captured in there and not clog up those perforations in the pipe. Periodically, it needs to be checked. You certainly can have it get compacted or plugged at times and needs to be raked off. And since it is wood chips, they will break down over time, but seems to be 3 to 5 years has been the time frame for a full swap out. And those chips just go back into the process. So nothing's wasted, which is the goal. Just a close-up look at the pipes. These pipes are the HDPE, high density polyethylene. They're much more durable than PVC, which we used on earlier projects and is appropriate in some settings for small scale systems. But these are durable and can hold up to impacts and resist crushing. And I'm still amazed today that these perforations, in this case, probably spaced a foot apart, 3/4 inch holes, are enough to pull enough air to effectively aerate and get the oxygen into the piles, but also bring all that hot vapor into the equipment and do the heat recovery. So in this case, the pipes will be set into trenches as the design plan for Windham. Another look at the site once in operation. What I like calling out here is, again, we're operating in the negative aeration mode the vast majority of the time. But you can see the active piles here on the right above those different aeration trenches. And you can picture the vapor being drawn down and it goes into pipes underground, goes over to the sump at the left, goes into the container where the blower, the heat exchanger, the valve controls are. And then at the very end, you can see a little bit of steam coming out of the exhaust. So if you're in recirculation mode, that exhaust would get pushed back into a pile, again, that was cold or dry or could otherwise benefit from the heat. If you're at an urban setting or commercial setting, and Brattlegrow being the case, this vapor can be directed into a wood chip biofilter as an extra measure for odor mitigation. First strategies are always recipe management, having enough carbon in the mixture, making sure there's adequate oxygen. So the biofilter is what we would call a multi-barrier approach, and that's worked well at other settings that we've had installations. Here's our lead engineer, Vice President Jason McCune-Sanders, with one of our units. We've either put one or two of these arrays inside of a 20-foot shipping container, or can have them on a smaller skid frame. But again, this is what's inside of those containers, where the pipe ports are on the back wall. The pipes come in, a controlled series of valves and gates can isolate which pipe and which windrow is being aerated. This is the heat exchanger here, which is like a specialized radiator heat exchanger that's corrosion resistant. Connects into piping where we can direct the hot water and glycol mix. This green and yellow equipment is in this case, a 3 horsepower blower. This is being assembled at our shop, so we usually don't leave them disconnected once we're on a site. But this is where the blower would put that suction on those piles that could be anywhere from 150 to 300 cubic yards of material, and effectively pull the vapor through. And then again, the pipe can either head out to exhaust or be redirected through a second plenum and series of controlled valves to recirculate into a batch. All right, then the fun part, we got into planning after looking at existing maps and aerial imagery. Jason and team pulled together some new maps that we brought down to the site, and this is back in 2021, and do some on-site checking. So we've got some ideas on paper, and then we go out there with the 200-foot tape measure and take a bunch of notes on the pad and talk about everything from equipment flow to trucks coming into the site, to the slope and the pitch and the runoff, how materials will be transferred from one phase to the other. So all those things we can kind of ground truth and check. This area, for example, is probably where the aeration facility, the equipment, and the biofilter will be located, on the kind of south to southeast corner of the site. So this is the district property and the neighboring wood processing facility across Ferry Road, Old Ferry Road. So then the process of planning and design goes from kind of more generalized drawings of overlays covering the baseline conditions and initial proposal, and then it's call it an iterative process, meaning we go back and forth. So it's talk through what are some of the efficiencies or shortcomings of these different layouts, and then also at the same time get into a budgeting exercise. So obviously things like the building is a huge expense. So if the building needs to be bigger, that's going to add tens of thousands of dollars to the whole capital cost. How can we minimize the covered area? How does this tie in with compliance? Bob mentioned one of the big drivers for this whole endeavor was to remain in compliance with Vermont DEC solid waste and stormwater rules. Well, since the site is so relatively small, there's not an effective space or a cost-effective way to put in a detention pond. So how do you reduce the risk of leachate? Well, cover your raw materials that go in. So just a quick narration, and we'll keep revisiting this, but trucks would come in, tip their loads at this front end of the site, receiving blending an area, and then the windrows will get placed in this covered structure for the first aeration phase and achieving the process to further reduce pathogen, the time and temperature requirements, before then being moved out to turn windrows to be more like the process that already exists now, but the material will be significantly more stabilized going into the windrows than it is by exclusively turned windrow process. A couple other views just to help ourselves, partners and regulators visualize what's being planned here. So this was a later stage of the design, and what for the most part is still the same. At one point, the orientation of the building changed, and the mechanicals are put into the southeast corner here of the site. But this big green area in the front is the vegetative treatment area. And these horseshoe or staple-like structures are compost filter berms to be placed around the end of the windrows. So these were measures that were taken to minimize the potential for any sediment or nutrients to reach off-site or nearby surface waters. So the idea with the pitch of the site sloping generally from east to west is we do our best to contain anything from the tipping and receiving area with a wood chip berm, and then likewise during the windrows phase, and then anything that does come off the driveways or around the pads has a vegetative treatment area to also reduce that potential for sediment and nutrient loss. A little more detail, and this is also tied into one of the aspects of the permit, is including a facility management plan. So some of these things are also repeated in the narrative of that application, but here's a visual to call out the sequence of loading, of batches, and they're turning within that. A little detail on where the aeration trenches are embedded into the working pad, a view out front of where wood chip filter berm would be around the tipping and mixing area, how the received materials are blended and loaded daily. So a little more detail, both to help the project team as well as regulators look at the approach. And then here is Sanborn Head is the engineering firm, licensed engineering firm, primarily looking at stormwater, but they're also doing the kind of the master plans for the site development and stormwater. So a little more detail than you can see. I won't try to expect anyone to read it, but this is what would go in the actual permit application, and it covers all of those details of where things are located, their setbacks. And then in the case of this application, because of the site size, some variances had to be requested. So those had to be well documented, both for what they are specifically, justifications, and what extra measures are being taken, such as the berms and the filter area, to accommodate that request. And Bob, you can just jump back in at any point here, but the process that Bob and I really wanted to share in this presentation is, while it's painfully long to go through all of this and get the funding and go through all the sequence, I think we're both very complimentary of the guidance and feedback we got from the DEC staff, Ben Gauthier in particular, Dennis Feckert, and then working with Bob's team, John Fay and Jason Kuhn-Sanders on Agrilab, that not like they told us exactly what to do, but we were able to share different drafts at points in the process and review their questions. In many cases, it was just a matter of us clarifying, but in other cases, we had to go back and sharpen our pencils and make sure we were following the guidance and actually comply with the requirements that are a bit more stringent for a medium facility versus what the district currently has. But Bob, go ahead and add in here, because well,
let's go to the next slide. You covered that nicely, Brian.
Okay.
So one of the drivers of the building enclosure is leachate management. And under the DEC compost regulations, for a medium food waste facility, which I described, you have to collect and treat leachate or prevent it from occurring through an enclosure, like in a building, which is, go to the next slide, please. What we opted for, we had an engineering evaluation of the cost to collect leachate, build retention ponds, pump them out. We don't really have much need for reusing runoff water in the facility. Moisture is sort of our enemy. So hauling it to the town of Brattlegrow wastewater treatment plant could be very expensive. So this is where we're at now. We are at a budget of approximately $700,000. Again, we want to continue the current operation and integrate that into the construction phase. We're planning to put a total new gravel pad on that dirt area that you saw in the photographs. We would use a fabric building, much like many towns use for salt storage or equipment storage. They're basically temporary buildings on concrete blocks. We would put a concrete slab, as Brian described, with aeration trenches. It allows us to capture the heat. The heat is important for process acceleration as well as potentially drying product. I sure wish I had that this month because we've had so much rain. We're having trouble keeping up with our screening. We're adding the extra biofilter for odor treatment, although we've had no odor problems at our site. And the new capacity would double what we currently are allowed in terms of cubic yards of food scraps. And it permit is quite generous with up to 40,000 cubic yards of organics, but we doubt we'll get much above 10,000 cubic yards due to the small size of the site. So next. Again, how do you pay for such a thing? My board is comprised of 19 rural towns that are very adverse to any long-term debt. Our district is controlled by 19 towns, and they will not accept any long-term debt. So they said, figure out how to finance this, Bob. And that's really been a challenge. But the board stepped up big time last December and said, we'll put $225,000 down. And they actually appropriated it and set it aside, which was a significant move on my board's part. The USDA Community Facilities Grant Program has awarded us $150,000, but it's a very, very arduous application process, and I'm still not completely done with that. But I'd do it again if I had to. Vermont DEC, the Agency of Natural Resource, has had, and that was in the Deputy Commissioner's presentation. We were one of the 2 sites that's received a couple of these grants, but we just were awarded this spring $277,000, which is calculated on 40% of the project cost. And then we have a long shot at a US EPA solid waste infrastructure grant, which we put in for $1.2 million, and it would be an increased cost where we would pave the entire site and also install a mixer for blending feedstocks. Quickly pushes us up above the $700,000 we now anticipate. Permitting has been interesting. We started out this recent December, filed a permit application for the facility, and then the DEC staff said, hey, Bob, your 10-year permit for your whole facility is up next March. Let's roll this application into that. And again, another example, in my opinion, of DEC working with us to expedite this. So the DEC permit for the recertification of our entire facility, which includes household hazardous waste collection, transfer station, baling, cardboard, multiple solid waste functions, is now in a draft phase and up for 30-day public comment. The town of Brattlegrow in December awarded us a zoning permit. Because we're adding a new building, the town zoning district that we're in actually allows for composting. It's an industrial zone. So that wasn't a question of whether we needed a special permit. Then our stormwater permitting is well underway. We have a few more details to get that in place. And then in Vermont, there's a statewide Act 250 permit, and we have to amend that to include this facility. Next. So we're going to wrap this up here. I think we're on time. We need to prepare RFPs. USDA requires it. Our own solid waste district purchasing policy requires it. So we'll be doing RFPs for various components. We want to do those in the next couple of months and select contractors so that this project could be implemented relatively before the end of the year. The stormwater management, as I said, is underway. This week, we're going to have some test pits dug and confirm soil infiltration. We've retained a local construction management firm, Steve Horton, to work with Sanborn Head on our bidding and overall project construction management. We keep updating our budget projections. It has obviously gone up. Then we'll select a general contractor and hopefully start construction this fall and get it up and running by the end of the year. We're then going to be able to actively solicit additional food scrap generators. We put that on hold as the facility permits were being exceeded, and we have various generators that are anxious to direct their materials to us. Next, I think that's it, and I'd be glad to turn it over to Natasha.
Yeah, thanks. We do have some questions that came in from chat. One asks, when pulling air negatively, does that air have less oxygen in it? And how does it affect forcing the warm air into a fresher pile? Do you need to force more than enough to compensate for less oxygenated air?
Great question, and I'll take that one. So fortunately, one of the things we have are sensors on the ductwork where we're drawing the piles. So I'll say in a 30-minute aeration cycle from a compost pile, initially, if it's a fresh active pile, you may see very low oxygen levels, down to 1% even. You can imagine that pile may have been sitting dormant for, in an aerated system, at least a couple hours. If it was a turned windrow system, that may have been sitting dormant for several days, and that oxygen may still be available to the outer layer of the pile that's 12 inches deep. But again, that's why the process slows down. That core of the pile, all the active biology is consuming that oxygen, and the rate of decomposition slows down, or it starts to go into a slower anaerobic phase. So you can actually see over a 30-minute aeration cycle that oxygen levels will go up. Historical evidence, or not evidence, but research has said that 5% is kind of the minimum to hit aerobic conditions in a pile, and that 15% is optimal. We tend to shoot for 10% with an early pile, that we want to at least get up to 10% oxygen, so we track that. So then to preface that, to answer your question, we wouldn't put on the recirculation to another pile until we're hitting something like that 10% oxygen, because absolutely, if we pushed oxygen starved air into a fresh batch, that doesn't help it get started. So we monitor those oxygen levels and then set the timer. So to hit it would go into recirculation mode once it's at a sufficient oxygen and temperature level.
Great, thank you. Another question is, does the design take into account the existing equipment to manage the windrows? And if so, would you recommend different equipment if funds were available, and how that might improve efficiency?
Well, I can respond to that. We're going to continue using our existing equipment, basically the front end loader, the backhoe with a smaller bucket, and our trommel screen. We don't, other than the aeration system, we don't anticipate any other new rolling stock or other equipment. The $1.2 million wish list includes a mixer to blend materials. So fortunately, we're just working with what we have to reduce capital costs.
Another question is, do you need to correct for moisture loss during the initial aerated phase, and how much moisture loss is typically observed?
I'll take that. Yes, aeration certainly liberates or dries out more moisture or dries out the piles more so than a typical turned windrow. So correcting for that is done at a couple points up front, where you might start a turned windrow pile at 55 to 60% moisture. These aerated piles would be started at 60 to 65% moisture content. So you're able to start it a little wetter. Then during the process, there is going to be water and recycled condensate available. So if at different points in the process, it's determined that a batch had dried out more than desired, there's the ability to reintroduce some moisture into the pile. Because absolutely, that's something to be aware of. And as much water as we have now, there's certainly times a year in recent summers where a compost process can get limited for a lack of moisture.
Great, thank you. And I think this last question will be directed likely to Bob. To what extent do you anticipate additional tipping fees from expanding capacity might benefit the project?
We are not planning on increasing tipping fees.
But if you're able to take more customers because you have more capacity,
yes,
there might be an increase.
So that will generate more revenue in terms of tip fees as well as product to sell. So we're pretty confident in this financial model. This compost facility is a profit center currently for the district due to relatively low operating costs. So we were very cognizant of not significantly increasing operating costs. In fact, there's going to be some decrease in operating costs by not having to turn the windrows for the first 3 weeks of aerated static pile, and also drier material for screening will accelerate our production of finished product, and also reduce the amount of residual we have for disposal. So there are some plus sides economically from this to offset some of the higher operating costs.
I would just like to thank Brian and Bob for sharing this case study. Very interesting. I always love to hear all the technical details. I think it's very valuable. And thanks so much to all of our participants for spending your afternoon with us.
Thank you. Yeah, happy to share.